Hello everyone and welcome back to my YouTube channel. This is an ongoing series where we're learning to build and optimize RAG workflows with LangGraph. Now in the earlier video, I think the last two videos we learned about a couple of ways where we can optimize our context, and then we'll just continue with the same. We'll look at yet another technique where we can enrich our context so that when the user query is passed on, we can get better retrieval, right? So this technique is called as semantic chunking. um, you might probably already guess by the word what this is, but let's take a look, right? Now in the previous video we briefly looked at the trade-offs of chunking your document into a larger chunk or a smaller chunk, right? You could have your whole document, you could have a chunk size, say let's say 1,000 or something, and we could have two or three paragraphs, and that's fine. You could also break it into smaller chunks, let's say something like 500. So that would mean you will get slightly more chunks, and your information is now captured within a specific chunk, right? But the core issue with both of them is that in both the cases we are still choosing a fixed chunk size, right? Be it your smaller chunk number or a larger chunk number, this is always broken based on the token count. Now what is the issue here? The issue comes because information is not always stored in specific tokens, right? Like let's say you have your let's say our own PDF, right, which is about LLMs. Let's say we have a certain section called as the transformer architecture, right? So what will happen is you'll have first few lines that define what a transformer architecture is. Maybe the next few lines will go in detail defining or giving a bit more explanation of this, and then you might have some information as to the stages of building a transformer architecture, maybe finally some examples of the systems that's built based on this architecture and so on, right? So as you can see how the information is split, it's never a fixed length, right? Now if I were to split it based on fixed tokens, what will happen is let's say I'm going to make a chunk here, right? And then let's say I am making one more chunk here, right? So this will be one chunk, this will be my other chunk, maybe one more here, right? Third chunk, and finally the fourth chunk would be this. So if you see, this chunk number one has information that is like both the definition and a bit of the detailing of this topic. My second chunk has parts of this and part of this. Third again has this and this now, and fourth is fine. We have part of this, but the actual information, the context from the previous one might be missing. So you see where I'm going, right? The major drawback of using a fixed chunk length to break our chunks is that we will have information that may not be the most appropriate one, right? Now of course you can use a chunk overlap, but even with overlap your actual chunk is fixed length, right? It's just that you are extending your context size to add have an overlap with the previous and the next chunks. So if both of them are picked up, you have a sort of coherent information. So this is where something called as semantic chunking comes into play. What this does is it breaks your document into individual sentences, right? I mean, if you were to do it manually, you could do it as you wish, I guess. But here we'll be specifically looking at a chunker that LangChain itself provides, and how that works is it breaks each document into sentences, right, and finds the cosine similarity between this one sentence. Let's say this is one sentence, this is one sentence. Let's say we'll just make few sentences, right? This is one sentence. So it's going to find the similarity score between this sentence and this sentence, right? And we'll have a certain threshold. So let's say these both are quite similar, so it will take these two now, and then it will compare these two with the next sentence. Let's say this is also has a good or like a very high similarity, cosine similarity. So this will get added, and let's say when it goes to this one, it the threshold falls down, right? So maybe the similarity score is not up to the threshold now. So what it'll do is it'll create a break here, right? So it'll create the chunk break here, and we end up with this as your one chunk. And it's very likely that this one chunk maybe speaks about certain aspect and has the coherent information here, right? And similarly it goes on with the next chunks, keeps comparing sentence by sentence, and then you form your next chunk. So maybe this is just 3 lines, and maybe this is, I don't know, 5, 6, 7 lines, right? So we never break the chunk uh, randomly at some word or in the middle of a sentence, just to follow the chunk size. Here we are looking at the sentence level, and we're using similarity score to do the matching, yeah, to do the comparison. So it's always going to be a few sentences that are packed together inside a chunk. So that's in a sense how semantic chunk works. We're looking at the underlying semantic meaning to do the chunks. Now let's go into VS Code and see how this works in practice. You have your function definitions. I mean, you import the libraries. We'll create new embeddings again. This time we'll use um, yeah, so we don't define unlike the previous ones, right, where we had to chunk. We use something like a recursive character text splitter, and we define the chunk size and chunk overlap. Here we don't do that. You simply call this chunk semantic chunker from LangChain themselves. We define the embeddings that we want to use, and we define a breakpoint threshold type, um, and a breakpoint threshold amount. Now there are, I think, 2 or 3 more types. So this is basically how you want to define the threshold. I think one of the other types is a standard deviation, but percentile is more intuitive. So when I say a percentile of 90%, any semantic match that goes beyond that falls below 90% won't get is when you break the chunk and move on to the next sentence, right? And the remaining vector store definition, saving it in the local, it's all the same that we have seen in the previous workflows. We build this semantic chunk only once, so that happens here, right? And the consecutive times it will simply be in the local, so it will pick up from the path and load it onto our workflow, right? So this is your indexing with semantic search, with semantic chunking, and all the others are pretty much the same, right? We have the retrieval step, augmentation, and generation. So everything is the same that we have done in the previous steps. You can go through them. Yeah, so this is linear workflow. What we'll do now is maybe test a query. So the question I have here is, what are the steps involved in training a language model? Yeah, there you go. So we'll now move to Langsmith, a tracing tool from LangChain themselves, to see how the intermediate steps, or like how the semantic chunk actually works. We'll give it some time. Yeah, there you go. So the steps involved in training a language model based on the provided context are as follows. We have got some steps. I think the answer is fine, but what we are mainly focused on is to see the working of the underlying semantics chunking, right? So let's go into Langsmith. Maybe I'll refresh this. Yeah. Yeah, so we have our flow here. Uh, um, did this UI change in between? It was just quite different until the last video, right? Okay. So you have your docs like this, unlike the, I think I like the previous one. The metadata were easier to read back there. But yeah, anyway, coming back to our workflow, at the, yeah, let's just check the overall flow, right? Let's see, where do we have the context? Yeah, so this is the first what do you say, the document that it's picked, and maybe let's just try seeing where this is within our PDF. Where is my PDF here? If I were to search this, oops, there are quite a lot of them. Maybe we'll search a longer sentence, um, and see. Well, by the way, I can also look at the metadata and find the page number, I guess. Yeah, so here, right? So six chapter 1, I am assuming it is this. Understanding language models is this. But let's just see how it is chunked, right? Understanding large language models, this local implementation can significantly reduce, that's probably this sentence. And it is stopped at without any labeling information. And where is that? Without any labeling information over here, right? So in essence, this entire paragraph has been chunked. I think we can already see, right? It didn't quite chunk at randomly, let's say somewhere here or somewhere here, and called it the context. But it has looked sentence wise and has picked up like this whole paragraph. This is in brackets, so I'm assuming it's just some extra information. So it is picking up one whole paragraph where the semantic meaning was close enough. Maybe let's look at another page content. We'll look at the fundamental idea of GPT. Let's search for this as a blueprint to tackle. This is there. Right, fine tuning. I think it has also picked up these ones. The extraction might have picked that. Right, so stage C. Yeah, so in essence, it has picked up all of this, like from here to here. I think this is also good enough, I believe, because normally if you were to enforce a fixed token usage, it might start somewhere here but end with here, right? It might miss on some of the later stages of your training model. So I think you understand where I'm trying to go, right? Now, one drawback in example like this in our case, is that the whole of PDF is about LLM, the transformer architecture, encoders, decoders, and so on. So the similarity score, or like the cosine similarity aspect might not really work here, simply because something like this, um, you have LLM words here, you also have LLM here, you have some fine tuning, maybe some words here that have closely related meanings, right? So it might abruptly cut off something, or it might end up just adding a lot of them simply because they have similar scores, and may not be quite right in our use case. But I guess we've understood the underlying working, right? Where it might be most useful is maybe in cases like in a RAG workflows, where let's say you're building HR documents. uh, there you will have different policies, right? So maybe one policy speaks about a certain aspect of the company, the second policy speaks about something about the employees, right? So here when you implement semantic search, it's going to break down these sentences accurately based on the underlying meaning, because there you will tend to have a difference in the underlying meaning across the various paragraphs, right? Now of course, here too, right, this paragraph might be totally different from what we let's say somewhere here, right? That's not the point. The point is, because it's comparing nearby sentences, um, this sentence is going to be closely related to this, this is going to be closely related to this, right? And maybe this is related to this. This may not be related to the first sentence, but as you see, progressively when you go sentence by sentence, the meaning might be more or less closely related. So not probably the best use case in a PDF like this. But like I mentioned, maybe HR policies, or maybe let's say you have some chatbots that's built on some companies' refund policy and so on. Here you have uh, not refund, that becomes a niche then. Let's say some customer experience perspective, right? You have various policies and various aspects that the chatbot has to cover. A RAG can be useful in cases like that, where the actual meaning or the underlying meaning of these sentences are going to vary significantly over different paragraphs. So I think that in essence is how semantic chunking works. I hope it was a useful video. In the next video, we'll look at something called as contextual compression. Probably the last video in context enrichment, and after this we'll move on to looking at some techniques within retrieval, and look at how we can optimize them. So thanks for watching this video. If you found it useful, drop a like, and if you have any questions, drop it in the comments below, or you can also reach out to me on LinkedIn. I'm quite active there and I'm happy to help. Thank you.